Determine the left end and right end behavior in the horizontal asymptotes, if any, or slant asymptotes, if any, for f of x equals x squared divided by x plus 1. If the highest power in the numerator is less than or equal to the highest power in the denominator, f of x will have a horizontal asymptote. If the highest power in the numerator is greater than the highest power in the denominator, f of x will have left end and right end behaviors of positive infinity or negative infinity. If it is exactly 1 higher, this will happen through a slant asymptote. F of x is x squared divided by x plus 1. The highest power in the numerator is 2. The highest power in the denominator is 1. The highest power in the numerator is greater than the highest power in the denominator, so f of x will have left end and right end behaviors of positive infinity or negative infinity. Since it is exactly 1 higher here, 2 is 1 higher than 1, this will happen through a slant asymptote. F of x will have a slant asymptote. And the slant asymptote is found by dividing the denominator into the numerator through long division. The first thing to do is to determine what the first term needs to be multiplied by to match the term here. To make x become x squared, we need to multiply by x. The x is put up here, and this entire thing is multiplied by x, which will give x squared plus x. It's now put in parentheses and subtracted. X squared minus x squared, they will cancel. The minus also distributes on the x here, giving a negative x. We now need to determine what this first term needs to be multiplied by to match this. That'll be a negative 1. That's put up here. This entire thing is multiplied by negative 1, which is negative x minus 1. It's put in parentheses, and the entire thing is subtracted. Negative x minus a negative x, those will fully cancel. Minus a negative x is a positive x. The negative can distribute on the minus 1, which will make it a positive 1. The first term, x, cannot divide any further into the 1. So the 1's the remainder, and it's put up here over. It's still being divided by the x plus 1. The slant asymptote will be y equals the linear function here, the x minus 1, without the remainder. Now to show that this is the case, f of x is x squared divided by x plus 1. After long division, this can be rewritten as x minus 1 plus 1 divided by x plus 1. The slant asymptote is determined by y equals the limit as x approaches positive or negative infinity of f of x, which after long division is x minus 1 plus 1 over x plus 1. The term 1 over x plus 1, the remainder, will go to 0 as x approaches positive infinity or negative infinity. What's left over is x minus 1, and that is the slant asymptote, y equals x minus 1.